Hello there, everybody. Miss Brown here. So today is Monday, but the instructional video will be for Tuesday, October 6th. And today we are going to be able to explain how electrical energy moves throughout different materials in a circuit. So that is our learning objective. That is our goal for the end of this lesson. So let's go ahead and get started. So a couple of weeks ago, we started talking about energy, and we started talking first about the two states of energy. And the two states of energy were kinetic and potential. The two states of energy were kinetic and potential. And that kinetic energy was active energy. So an example is running, jumping. Potential energy, that's that stored energy. So a ball at the top of a hill, it's not moving, it's not rolling down a hill. It's a ball at the top, resting at the top of a hill. And then the three forms of potential energy, we have chemical, and then we also had gravitational and elastic potential energy. They're not on here, but an example of chemical energy is battery, fuel, and food. So it's pretty much like the food. It's fueling your car, food for your car, food for your remote, food for your body. It's that chemical energy is stored, and then when we digest it, when it goes into our cars, that energy transforms into mechanical energy. Then we were talking about the forms of kinetic energy. So one of the forms of kinetic energy, we have mechanical energy, and that's gears turning. So another example of mechanical energy would be Miss Brown jumping up and down, or Miss Brown fist pumping in the air. That's mechanical energy, that energy of motion. We have electrical energy, so a toaster being plugged into an outlet is an example of electrical energy. Miss Brown has her laptop plugged up to the wall, so my laptop is using electrical energy, and that electrical energy is being transformed into light energy so that I can see my PowerPoint and see the screen, but also sound energy so you guys are able to hear me in this video. Then we have thermal energy. That boiling pot of water is an example of thermal energy. Heat. Anything dealing with heat is thermal energy. And then lastly, we talked about sound energy. So a musical instrument, being able to hear Miss Brown through your laptop, that's another example of sound energy. So those were the different forms and types of energy. Remember, you guys will be having a test next week, and so it's important that you know these forms and types of energy, specifically different examples on kinetic and potential energy. So that is a little hint right there. All right, so today we are going to be talking about electrical energy more in depth. So if you see Miss Brown, little Bitmoji is thinking and she's pondering. She's pondering and thinking about that question that is in the bubble. It says, do electric charges flow freely through everything? Let's think about that. Do electric charges flow freely through everything? Well, it's flowing through my laptop charger right now so that my laptop is able to charge. It's flowing through my phone charger so that my phone is able to get charged. It's not flowing through this piece of towel that I have. I'm not getting any electricity flowing through that. It's not flowing. It is flowing in this remote battery. My battery's dead now. All right, so the answer is no. Electrical charges do not flow freely through everything, which that's kind of a good thing, because I would not want that electrical energy to be flowing through this towel, and as I'm touching it, it's zapping me like Bart Simpson in that previous gift. So it says nope. That is where conductors and insulators come in. So that is what we are going to be learning about and taking notes on today, conductors and insulators. So go ahead in your science notebook and write these two words, conductors and insulators. All right, so let's go ahead and start talking about them. So we have insulators and conductors, and first we are going to talk about insulators. So insulators are materials that do not allow electrical energy to flow through. They don't allow that electrical energy or energy at all to flow through. Some examples are rubber, glass, wood, and yarn. And if we see in our circuit, we have a complete circuit. We have our battery, we have our wires, we have our source, what we're trying to light, our light bulb. But there, instead of using a wire right here, I used a piece of yarn. And you can see that my light bulb isn't lit. So, but that goes to show, because we said that an example of insulators are yarn. So when I have that yarn right there in the place of a wire, that's pretty much making my circuit an open circuit. And we know if a circuit is open, then that electrical energy isn't able to flow and my light bulb isn't able to be lit up. So insulators do not allow energy to flow through. Conductors, on the other hand, so if insulators don't allow energy to flow through, what do you think conductors do? Conductors allow materials to flow through them freely. So materials through which electric charge can move freely. So a conductor allows that electrical energy to be able to flow, and it is working, and that electrical energy is cruising through. Remember, a conductor is pretty much telling something or someone where to go. And so our conductors in a circuit are the wires. So what are the wires made of in our circuits? What have we been using? What do you think the wires have been made of in our circuits when we've been making them on PhET simulations? An example of conductors is water and metals. So metals are good conductors. So metals such as aluminum, copper, and gold. So you see in our circuit here, we have our battery, we have our light bulb, we have our wires, and then instead of using yarn, I used a little copper bar. And we can see that our light bulb is shining ever so brightly, which makes sense because conductors, copper is an example of conductors. So that electrical energy is able to flow through and pass through that bar of copper, okay? So on this picture, we have some more examples of conductors. Remember, conductor is any material that allows an electric current to pass through. And an insulator is any material that does not allow electric current to pass through it. So some more examples of conductors: copper, aluminum, steel, any metal. Insulators: plastic, rubber, glass, and cloth and wood. However, I want us to take a look at this part right here, because we have an insulator and a conductor, and we see that kind of looks like my charger right here, my laptop charger. And so why is it important that, because if I were to cut this open, which I'm not going to because then it wouldn't work, but if I were to cut this open, I'd be able to see those wires, those metal wires where that electrical energy is flowing through. So why is it super important that there is an insulated part, this rubber part on the outside? Why do you think? Because if I was just touching those metal wires right now, I would be getting shocked with electrical energy. And that is not a good thing. So that is why it's good that we have an insulator on the outside of a conductor. You can see it in our chargers. You can see it in whatever electrical outlet, electrical plug that you are using. It'll be like a rubber lining. Here's another example. There's the rubber lining on the outside, and if I were to cut it open, it'd be the wires, and that is where that electrical energy is able to flow through, okay? All right, so a few reminders and announcements. You guys will be having your test on next Tuesday, the 13th. It will be over energy states, forms, and transformations. I will upload your study guide onto Schoology. So after you watch this video, you can go into Schoology. It'll be in the Unit 2 folder, and check out your study guide and start working on it. That way you can get some extra practice and help for your test. Also, Ms. Brown weekly calendar for you guys, and I upload it in Schoology, and so this helps you kind of know what your assignments are for my class, just science for the week, and when they are due, and the titles, and just to help you kind of stay on track. So I'm going to show you guys a video on how to access it. So you'll click on your science class, and then up at the top it'll say weekly calendar, and then you are going to click this week. So today is October 5th, and then when you click on that, it'll load, and still loading. Voila, there it is. So it has Monday, Tuesday, Wednesday, Thursday, what we're talking about in the live group sessions, on the Microsoft Team live group sessions, and it also tells you what your assignments are for that day. It tells you when the assignments are due. There are plenty of places, so the assignments, it gives you your assignments on the bottom, on the right-hand side, and each day, and it also tells you Ms. Brown's virtual office hours, so when I'm available to answer any questions, okay? So that is in Schoology, in the weekly calendar folder. All right, next, if you have not created your Gizmos account, you have to, because if you didn't notice, one of your assignments for this week is actually a Gizmo lab. So you need to create your Gizmos account. And so if you don't know your access code, that is okay. I showed you guys how to get to that in the video from Thursday of last week, but I also uploaded it. If you click on the instructional video, so I'm sure you saw it when you viewed this video today, you click on the instructional videos link, and it has Monday, and then it has first period, second period, and third period. Make sure you sign up for the correct period. Make sure you sign up for the correct period. If you don't know your class period, go into Microsoft Teams and look and see, do you have a class that is titled first period, second period, or third period? So it's super important that you sign up for your Gizmos account, because we are going to be doing an assignment in it tomorrow on Tuesday, and you will have to turn in an assignment for the Gizmos that will be due by Thursday. All right, if you have any questions, as always, never hesitate to reach out and let me know. I look forward to seeing you guys tomorrow in class. Bye.